recording. Good afternoon, everyone, and welcome to AICC's webinars. Today's webinar is Rotary Die Cutting Operations with Eric Alton, who's with Sun Automation. I am Taryn Pyle, and I will be hosting this call today. If you are new to AICC's webinars, we want to welcome you. Please feel free to reach out to AICC at any time with regard to all the different webinars and programs that AICC has to offer. If you want to learn more about those offers, you can visit our website at aiccbox.org, or you can call me or Chelsea anytime, and we'd be happy to help you figure it all out. You can find information on the courses and our upcoming packaging school and webinars under the Learn tab on our website. We have a few housekeeping details before we get started. This call today will be 60 minutes long. A recording can be provided via the email upon request. Any materials discussed or offered will be placed on Dropbox, and you will need to download them to your computer. I do want you to know that on these calls, you can hear us, but we can't hear you. We do this because we are recording this session, and if you have a question, you can raise your hand using the hand feature on your dashboard. If you are on the phone, you can press star two, and this will raise your hand, and we can call on you directly. This is pretty informal webinars that we offer, so feel free to post in questions in chat, and we can interrupt this instructor and cover your questions during as well as after the call. As a reminder, we do practice antitrust, and there will be no discussion allowed regarding prices, customer market allocations, markets, or discounts. If this were to happen, we would have to end the session immediately. So we ask that you adhere to those rules. Now I want to introduce you to Eric Alton. He's the Global Product Business Development Manager at Sun Automation Group. And he joined Sun in 1988 and spent 25 years in Sun's engineering department before moving to sales in 2013, where he has been regional sales manager for North America, North American sales manager, and now global product manager. Alton brings extensive industry expertise and intimate product knowledge to Sun Automation Group, where he can quickly identify and solve customer needs. And Eric, welcome, but I also want to thank you. Sun Automation is one of our education investors. They were responsible for the creation of our packaging school, which is an online free education resource with over 100 courses available to you and the employees of the companies. And Sun Automation did a more in-depth course on the basics of rotary die operations, and today he's going to get more in depth with regard to troubleshooting and all the other secrets he has as it relates to rotary die cutting. So welcome, Eric.
Thank you very much for having me. And again, today's webinar is really corrugated 101, just talking about some of the basics of the rotary die cutting operations. As what was previously mentioned, there is a more comprehensive course within the packaging school that goes into a lot more detail of specifics of machine setups and some fundamentals of operating a die cutter. But again, today is kind of just an overview of those fundamentals, kind of just to whet your appetite of what the packaging school has to offer. And with that said, we're going to go right into it. So for today's agenda, again, we're going to talk about the operations of a die cutter, the units or machine sections of a rotary die cutter, and then we'll end with some maintenance and cleaning of the machine. For again, this webinar is really just to review an overview of a die cutter, specifically for those who maybe work in a sales office of a box plant or an accounting department, that see what is, they receive the orders on the machines, but they're not quite sure how the machines are making the product. So this course is good for, this webinar is good for those to understand what's happening in their box plants. And for those who do not know, again, going back to the very basics, there's two types of main finishing equipment in a box plant, and that's the flex folder blowers that make your typical RSCs. Your most common RSC that everybody is aware of is like your Amazon box. And then the rotary die cutters, which is kind of the workhorse of a box plant, and they cut a pattern in a corrugated sheet, very intricate patterns, And your most common die cut box that you will ever see is your typical pizza box. And that's what most people understand is being made from a rotary die cutter. So again, from rotary die cutters, they typically are produced in corrugated boxes, corrugated trays, corrugated wraps, and then your intricate retail displays. And a lot of the displays that you see in Walmart and Costco, you know, they're individual pieces of corrugated board being cut into very specific patterns and then assembled to make of the display. Corrugated boxes, obviously your pizza boxes, your trays. If you go into any BJ's or any of the produce warehouses, you'll see all the tomatoes and lettuces all in corrugated trays, multiple colors. Typically, you know, 2, 3, 4 color trays. And in your proteins, you have what they call 5-panel wraps, and they can be typically 1, 2, 3 colors as well. Before we really go into it, the machine section, so a typical rotary die cutter consists of a feed end, print units. It could be multiple print units, no print units, or it could be up to 6, 7 colors. Your typical machine, though, in the market is around 3 to 4 colors. There's usually a spacer unit between the last print units and the die cut section. Some of the equipment manufacturers have built-in dwell space between all the sections. Again, some of the older machines that are in the market just have an add-on unit that's been placed between the last color and die cut. And that's just to give you some sheet separation from your last print before you start to die cut it. And then the die cut unit itself. Again, the purpose of the feeder, the feed end, is to feed the corrugated board into the machine. And then the print units apply the subsequent colors to the corrugated board, whether it's 1 color, 2, 3, 4 color. And then the last section would be to die cut the pattern into the sheet. And then the pictures, the illustrations that you see are of a traditional feed end in the wheel box area. The middle picture is just a sheet being transferred from print unit to print unit via a vacuum transfer deck. And then the last picture is of a rotary die cut form on a cylinder. Before we really start to go into the machine, let's understand what we're running on the machine. So again, corrugated 101 basics material. These machines are manufactured specifically for corrugated board. And a corrugated board is typically a top liner, a bottom liner, and then a fluted medium. They can be single wall, double wall, triple wall. There's multiple different types of paper grades to give a proven result in ETC values. Top liners and bottom liners are typically paper that's made with a very controlled directional fiber layout. And then the medium is a very randomly placed fiber layout, which allows the paper to form easily into the flutes. Flute sizes in our industry are BC together. E-flute is very common. And the flute sizes determine or make up the thickness of the board. And then we have our inks. So in corrugated, the most common ink is your traditional water-based flexographic ink. It's used in almost all corrugated applications. It's formulated to dry rapidly in corrugated board. And it does so while it maintains its body, its shade, and its color strength. There are other inks available in corrugated. You can have UV-based inks, which dry with the utilization of the UV lamp. Again, they're very special formulated inks. Now, going back to water-based flexographic inks, there's a lot of science in these inks, and it's all machine operators should know their inks should be formulated to their specific processes and the machines they have in place. Not all machines require the same ink. It depends on how the machine is specified. analog rolls, whether it's a vacuum transfer machine or pull roll machine, your substrates that you're running, whether they're brown craft or they're clay coated or they're chemies. All these factors determine how the ink chemistry is developed and formulated. So just be mindful of those inks and how they're being used on your specific machines. Also, the printing plates. Printing plates are in flexographic process or a polymer stereo plate, traditionally 250 thousandths in thickness, mounted to a backing plate on an average of 30 thousandths, so it gives you a 280 total. There are some plates that are thinner, and again, the stereo plates are manufactured to receive the ink from the analog roll and then transfer that ink to the board. Before we go into any of the parts of the machine, a lot of consideration is spent with operation safety. Operators should be well trained on the equipment. They should review all the manuals and of the machine itself and of the plant's specific safety guidelines. Before machines are started up and put into production in the beginning of the shift, operators should review the machine guards, interlocks, safety switches, and make sure all the protective devices are in place and operational and good repair. If they find anything that's not, maintenance and supervisors should be notified. Any spills around the machine should be promptly cleaned up. Scrap needs to be removed and disposed of in its proper waste locations. And of course, appropriate operator attire, no loose clothing, no jewelry, and should have your proper PPE on, gloves, steel toe shoes, hearing protection, eye protection. Some plants now require bum caps or hard hats. Gloves is relatively new. No loose clothing. All hair should be tied up and make sure that it doesn't is prevented from getting caught in the equipment. And before and after every shift, the operators should be reviewing their equipment and again making sure that all the guarding and components are in safe operation condition. And the rotary die cut operation is a very abusive one. Parts do rattle loose and come loose, and they could, guarding can come off. So it's good standard practices for operators to review the equipment again at the beginning of shift, at the end of the shift, to make sure that nothing is out of place, and if it is, notify the supervisors and maintenance departments. And obviously, all plants have their own lockout tagout procedures, zero energy safety protocols, and all that should be adhered to. And lastly, material safety data sheets should be reviewed. Operators should know all the chemicals that are in their plants and make sure they're aware of the precautions and the safeguards in utilizing those chemicals. So all die cutters have some type of control system within them. All the newer machines typically have like an HMI control platform. Some machines have HMI and traditional switches. Older machines are just switches. But regardless, there are some basic control outlines of all rotary die cutters. They all should have a normal stop, emergency stop. A lot of machines have some type of jam indicator. There should be a feed interrupt switch, a machine speed control, speed pot, or a device to control speed, zero stop, a run start, and some jog. Again, these are just traditional controls for the functionality of the machine. All machines have these, and operators should be well trained and versed on the usage of all these components before they actually operate the machine. And they all vary. Again, they all vary from manufacturer to manufacturer. Everybody controls the machines a little bit differently, but they all have very similar components. to perform those tasks. So we're going to talk about the first part of the machine, the feed section. And we're going to review the feeder setup, and a little bit of troubleshooting with the feed section. So again, the feed section is the starting point of the rotary die cut process. It is responsible for presenting the corrugated sheets accurately in a controlled rate of speed to the print and die cut. What we call an imaginary hopper, and a hopper is really the area between the front gates or stops, the side guides, and the rear backstop. In the pictures that you can see, the sheets are stacked in a manner in which the sheets are pulled from the bottom into the feed nip of the machine. These pictures illustrate the machine being fed with an automatic pre-feeder, but there are a lot of machines that are hand fed. So the hopper heights are maintained through operator manual labor. Reviewing the feed section itself. So there's a number of key components of the feed section. So you have a set of front scales that allows the operators to set the gates and side guides accurately, and visually allow them to see where the side guides and gates are. You have the feed gates themselves, which are the front stops, the side guides, which square the sheet on the side edges. The actual feeder itself is comprised of feed wheels or belts, depending on the manufacturer of the feeder. And then there's manual dampers within the feed box to where you can gate off the vacuum pressure and have it sized accordingly to the sheet size. And then the feed grate itself, which is the mechanism that raises and lowers and it allows the sheet to come in contact with the belts or the wheels. All of these devices, specifically with the feeder, the grates and wheels, they're all timed to feed the sheets into the machine through a very coordinated, precise movement, along with the wheels, belts, and grates, and the vacuum hold down. So in one machine revolution, one repeat diameter of the machine, the grate is lowered, allowing the corrugated sheets to come in contact with the wheels or belts. Wheels or belts accelerate the sheet to machine speed and presents it to the feed nip. Then the feed nip is responsible for controlling the speed of the sheet into the machine at a controlled rate through the entire length of the sheet. Now some, specifically the Sun feeder transmissions, allow for a stroke adjustment. We'll talk about that in a second. But the initial setup of a feeder, you need to be mindful and set the side guides to the proper board width. Vacuum doors should be open and closed according to your sheet size. You don't want to have vacuum pulling around the edge of the sheet. You want to have it concentrated into the center of the sheet. The backstop adjustments need to be made accurately. Your feed gates need to be adjusted accurately. Again, your stroke setting for the board has to be set accurately. Blower speed, some of the older machines didn't allow for blower speed adjustments. Newer machines do. Blower speed adjustments are really important if you're running multiple flute sizes. Specifically, E-flute sheets don't require as much vacuum pressure as a traditional A or B flute would need. And then the operator would then fill the hopper with sheets and start the feed, the machine and run production. Again, feeder setup, stroke adjustment. So stroke adjustment is not as important on rotary die cutters as it is on flexible forward gluers. Flexible forward gluers typically run a score line that's manufactured on the corrugator, and the score line would be your top or bottom flap on your RSC, your regular slotted container. The score lines vary dramatically on sheet sizes, and it's important not to have your score line fall in the feed nip when your stroke has ended in the transmission, because then you have misfeeds and jam ups. So more so misfeeds. So it's important to adjust the stroke accordingly. But on rotary die cutters typically don't run score lines. So what's most important with rotary die cutters is just to make sure that your stroke is not longer than the sheet that you're running. For example, if you're running a 19-inch sheet in board direction, you don't want your stroke set at 20 inches because it's going to try to feed the next sheet in the hopper within that same machine repeat diameter. So typically, box plants on die cutters, they find a happy medium and they kind of leave it. They do make some adjustments on drastic sheet size, but if they're running, 20 to 26-inch sheets, they probably don't change the stroke very often. But if they go from 26 to a 40-inch sheet, they would most likely change the stroke in that scenario. The backstop settings for the feeders is critical as well. Backstops they actually kind of form the hopper section, and they allow the sheets to lay flat on the feed tables, thus allowing either the wheels or the belts or whatever feed mechanism to have full contact with the sheet. Exaggerated, if the backstop was too high, the sheets would be tilted on an angle into the wheel box, and only maybe the first 1 or 2 rows of wheels would be in contact, and it would not, you would have feeder variation, registration variation, because the sheets being delayed and not feeding properly. So it's critical to have backstops set correctly. You don't want them too tight where they're wedging the sheets. Then you also don't want them too high or too low. As in the illustration shows, you want the sheets to lay flat against the wheels or the belts in the feeder. So a couple quick troubleshooting things to look at when it comes to feeders. If you're having some misfeeding and jamming, most possible causes are the vacuum blower not running. We hear that we find that quite often. Customers will complain that it's not feeding correctly, and they find out that the starter and the blower is burned up, or there's some kind of debris in the vacuum line that's inhibiting vacuum, which then causes too much or too little vacuum. Some of the other causes of backstop not properly aligned or adjusted, as I previously mentioned. Pile height too high. If there's too much weight in a hopper, it will cause misfeeds. If there's not enough weight in a hopper, it can cause misfeeds. So there is a kind of a happy medium to maintain. E-flute hopper heights are typically much lower than B and C flute hopper heights because of the weight of the paper. And when utilizing pre-feeders, you don't want to have the sheets dropping into the hopper on too much of an angle and too much of a distance drop, because then it causes misfeeds. Improper feed roll pressures will also cause misfeeds. Not, as I mentioned, not enough wheel tread in contact with the sheets. When it comes to sheet skewing, so sheet skewing is how the sheet is passed through the machine. If it's passed through crooked, there's typically what causes that are blowers not running properly. Again, too much or too little vacuum, feed gates not parallel, feed gate height not set properly. So there is a specific distance that gates are supposed to be gapped underneath between the board and in the bottom of the gate itself. Vacuum pressure not distributed evenly. Again, debris and dust and inhibiting vacuum doors to open and close correctly. Grates not moving up and down or not parallel to the wheel box itself. And that's typically because of scrap and dust being collected underneath the grates and within the wheel box area itself. So it's whenever you have feeding problems, one of the first things that you should always look at is the wheel box itself, and making sure that it's clean, that your wheel treads are not worn and they're even, and that there's nothing inhibiting the movement of the wheel box itself. Again, grates not in parallel or not lifting straight up and down. Wheel treads worn. Wheel treads do have life expectancy, They can wear prematurely depending on paper weight and grades. They, if you have jam ups in the feed gate area, they typically wear out the treads in that area sooner than elsewhere. Then we're going to talk about the print units themselves. So again, the sheet is being loaded into the front of the machine, into a hopper section, and then the feeder through the wheel box in the feed nip is now accelerated the sheet up to machine speed and is presenting it to the print units. And again, the function of the print units or print sections is to receive the individual sheets from the feed unit and allow for one ink color of coating to be applied to the sheet per print unit. So each print unit is responsible for applying one single color. The combination of several print units gives you the multiple color ranges. For example, your traditional 2-color pizza box can be run on a 3 or 4 color machine, but that 2-color pizza box is only utilized in 2 colors of that machine at that given time. The other remaining colors are just pass-throughs. Some of the key components of a print unit would be the analog roll system, the ink system, which really is just the ink pumps and the controls and the plumbing. And then there's the ink metering system. Today's machines typically utilize a meter and blade technology, whether it's single blade or dual blade. Some of the older technologies would be wipe roll. And then you have your printing plate itself, the printing stereo plate mounted to the steel print cylinder. Then you have your impression cylinder and then the transfer mechanism. And in the video that you're seeing, it's a sheet being carried through a machine via the vacuum transfer section. So we're talking about analog rolls real quick. So the purpose of analog rolls is to transfer a very specific amount of ink to the stereo plate, which then transfers the ink to the corrugated board medium. So analog rolls are engraved to very specific volumes. Most analog rolls today are ceramic laser engraved rolls. They're identified by the number of cells per inch, the depth of those cells, and the shape of the cells. And all these control the amount, the very precise amount of ink that's being transferred. For example, a traditional text block printing, for like on a pizza box, you may only use like a 220 cell count roll with providing a volume of about 8 BCM, and BCM is billions of cubic microns per square inch. It's the amount of ink, the volume of ink that's the analog roll is holding in a 60-degree shaped cell. Now, when you get into some of your screen printing and your vignettes, your cell count is going to go up. You'll typically see them in the 360 range. And then when you get into some of your 4-color process printing, your very high graphic printing, now we're talking in analog rolls in the 400 or 500 cell count with lower volumes in the 4.5 to 5 volume cells. Reason being, the high graphic printing, if you think about it, like with your computer or your television in pixels, the smaller the dots, the more you're getting within an area and the more crisp and precise the print image would be. The larger amount of dots, the very rudimentary ink laydown, which is needed for just some of your traditional block printing and this end up type printing. And again, the inks that are utilized in these machines need to be formulated to the analog rolls that you are running. One of the key components of the system is the actual metering system itself. This illustration shows a single blade technology. So you're using an analog roll with a polymer blade, and the system basically fills the cells of the analog roll with ink and then scrapes the ink away and leaves a fine layer, a thin layer or film of ink on the surface of the analog roll, in which only the cells themselves are filled with the ink. The ink is then transferred to the stereo plate, and the stereo plate transfers that ink dot matrix to the printing substrate. And then the cycle repeats itself. The printing plate itself, again, is a polymer plate. Typically, it's about 250 thousandths thick and is mounted, again, typically to a 30 thousandths backing plate. There are other variations of that. You can have thinner plates for higher graphic applications where they're running, 180, 190 plates. The plates are mounted to a print cylinder, as you can see in the illustrations, through a number of different ways. The most common traditional method is the Matthews locking system, which is a groove that's been machined or into the print cylinder itself, or it's been machined into a part that's been bolted into the print cylinder. And then for plates that are not full wrap plates, they use bands, of what you see in the lower right-hand corner of pull bands being applied. And these basically pull the plate taut against the surface of the print cylinder. What's important to know is the proper amount of bands should be always utilized. You shouldn't take shortcuts in this. There are other devices that are used in this application. So you do have some machines that are made to accommodate only full wrap plates, and they have an auto tensioning device that locks the printing plate onto the cylinder. There are other devices such as the Annan lockup system, which is kind of a ratcheting rod and reel system to pull the plate taut against the print cylinder. But it's very important to run the proper print cylinder or the proper plates to proper print cylinder. So if you're running 280 die and backing, you need to make sure that your machine is specified as such. If you bring in a machine, if you have an existing operation and you buy a machine from another location and it's sized differently, you will have a problem. So the print cylinders would have to be looked at and then replaced to accommodate the die and backing that you're using in your plant. Or you have to run very specific die and backing for that machine that's different than your other machines in your plant. One of the other key components of the print unit is the impression section. So the impression is basically another solid cylinder that the substrate corrugated board is being ran between, again, the impression cylinder and the printing plate. That creates what we call the impression gap. So basically you're supporting the back edge of the sheet while the printing plate is pushing up against it while it's being ran through the machine. The gap between the impression roll and print cylinder is adjustable. It's very important to keep this gap sized properly. And again, if you were to refer to the course in the packaging school, it goes into a little bit more detail and proper settings of gaps. This is important because you don't want to crush a sheet too much because it reduces your ETC values. So you want to be able to print and with very little distortion to the corrugated board itself. So you basically just want to kiss the sheet when the sheet is passing through that nip point. You also want to make sure that your surface speed is identical, meaning if your analog rolls are worn or if you're running the wrong plates, your surface speeds won't match, and then you'll have printing inconsistencies that you have to contend with. Almost all machines today use a vacuum transfer system. Vacuum transfers have been around probably almost 30 years now. And again, it's just a mechanism for transferring the sheet from unit to unit. Previously or prior to vacuum transfers, machines typically were made with pull rolls, and pull rolls for a bottom print rotary die cutter would mean a solid top roll and then pull collars on the bottom of the sheet. And typically your pull collars were moved to the outside edges, and operators would have to set these pull collars up depending on sheet size so as they could pull the sheet through the machine, but also not disturb the printed area of the sheet as well. The elimination of pull collars has improved setup times, thus why vacuum transfer is really the standard in almost all machine applications today. Again, it utilizes a vacuum in conjunction with hardened rollers or belts to transfer the sheet from section to section. Just a couple of print unit troubleshooting. We're going to talk about misalignment of printing and images. Typically, that's a registration issue. Printing plates not properly mounted on the print cylinder, loose. It could be loose Matthew straps, or a lot of times you'll see operators taping print cylinders in place so they don't move around. There are some adjustments that you can make through lateral adjustments and registration adjustments to get the images to overlay one another within tolerance. Then there's other things, outside factors that cause misalignments, sheet slipping, not enough nip pressure in some cases, not enough vacuum pressure in some cases. Printing plates worn, printing plates coming loose, the actual stereo, the polymers coming loose from the backing plate itself. Some of the other typical symptoms that you see in printing is inking too heavy. So when it comes to those types of issues, you're looking at your ink system itself. You have to make sure your blades aren't worn. Make sure your ink viscosity is proper, not too high, not too low. Make sure that all your nip points are set properly, and making sure that everything's clean. One of the biggest issues that we see on the machinery side when it comes to printing issues is really dirty ink systems. Scrap and debris caught in areas as inhibiting components moving correctly. Scrap and dust getting into inks themselves and clogging pump systems, dust getting into the inks and causing ink viscosity numbers to get too high. Some of the other symptoms to look at is making sure your ink coverage is correctly from one side to the other. If you see inconsistencies in this, you have to look at printing plates themselves, making sure that everything is parallel to one another. Ink smearing, again, worn plates, dirty printing plates, ink viscosity, sheet slipping. So as you can see, there's a lot of common causes and symptoms when it comes to printing. Most of them go back to the ink system themselves and the printing plates. That should always be looked at before you start looking at or assuming there's a mechanical issue with the machine. So you eliminate the basics, the simplest things first, and then you work your way into machine causes. And again, machine causes would be things coming out of parallel and worn parts. We'll talk about the die cut section. So again, the die cutter's function is to trim the printed corrugated sheet and make any special and very specific cut patterns to bring the product to its final configuration. As you see in the left-hand side, the picture illustrates vegetable trays, and then the cutting forms themselves. And again, the cutting forms in rotary die cutting are usually serrated knives embedded in a curved piece of wood that matches the diameter of the die cylinder. And then the cutting forms themselves have crease and rule within them, and they also have rubbering to eject the scrap where needed. The key components of a die cut section itself is, again, a transfer section to transfer the sheet from the last print to the die cutter itself. The die cut cylinders themselves, the anvil drum, die drum, and then the anvil blankets that are mounted on the anvil drum. So as a printed sheet is passed via the vacuum transfer section into the final print, into the nip between the die cutting drum and the urethane blankets, the cut pattern is from the die is transferred through that sheet. Now, it's important to make sure that your nip pressures are accurately set here. Your knives are supposed to penetrate all the way through the sheet into the ammo blanket itself. Typically, it's about 60 thousandths, 60 to 70 thousandths of impression or of the knives tips into the urethane. That ensures that you've cut all the way through your sheet, especially all the way across the span of the machine. And then there's rubbering within the die itself to eject the scrap and push the scrap down and have it fall out of the board path, and the scrap is collected through a scrap system and conveyed offline and moved elsewhere in the plant. So when you're setting the die forms into the machine, it's very important to open up your anvil nips. Typically, once you do so, there's an automated type of a system that will engage a gear train brake to keep the drums from rotating, so you can safely reach into the machine. But there will be some times when the drums have to be rotated in order for you to set your die form. So you typically do that through your registers. And again, the die forms themselves are marked, typically an A side and a B side, and then they have a center line marked where you can center them into the machine. And all die forms should be positioned and with the machine, the full nip in the open position. If for some reason you forget and you do it when the nip is closed, it will become, you could damage the dies. You could, the rubbering, you could essentially pull the rubbering out of the die and damage the knives. So it's important to do so with the nip open. So again, once you have everything, your die set, then you can go and adjust your gap back to the proper location. And that gap should be where the knives are, again, only penetrating into the ammo blanket no more than 60 to 70 thousandths. If you bury the knives too deep, you reduce the lifespan of the ammos, and you can damage the board as well, and damage the machine if they're buried too deep. Too shallow, obviously you're not going to cut all the way. You have very incomplete and inconsistent cuts, and then you'll carry scrap through onto the next part of the process, which is the stacker. Now some of these gap adjustments, and this is true not only for the die cut nip but also for the print nip and feed nip. Some of these are automatically controlled. Some machines have screens, HMI screens, where you can go in and adjust and send the gaps to the very specific dimensions. Some of them have switches to control those gaps, and some of the very older machines, it has to be done manually. They have knobs and hand wheels that you have to physically move and set the gaps and then lock them into place. So once you've set the machine, typically operators run a test sheet, and they'll run a test sheet with a little bit of a print impression and a very light die cut impression, where they're not cutting all the way through the sheet. So because they want to be able to see the cut pattern within the sheet. They will take this test sheet, and the operators should be measuring lead edge to the print, lead edge to the die cut to print, and make sure all these dimensions fall within their job spec. And if they are out of job spec, then the operators would increase or decrease register settings, nip pressure points, etc., to maintain the accuracy of those distances. Then once that is validated, then the machine is ready to run production. So they would then start running production. However, prior to that, one of the other factors that needs to be looked at is lateral register. So laterally across the span of the machine, you need to be able to make sure everything is within spec as well. And it is very similar to the register of the sheets in board direction. across the span, you can make adjustments as well. Print and die cut typically can be adjusted, and it's usually done manually, or in today's technology, it's done through a motorized device, either through the HMI screen or through switches. A couple of die cut troubleshooting things to review. The excessive wear of the urethane covers on the amble drum, too much impression is most likely your culprit there. Oscillator, so the amble drums, the machinery manufacturers design the amble drums where they can oscillate back and forth a specific amount automatically to give you a much more clean cut profile. If that mechanism is broken, then you're constantly always going to be cutting in the same area, which will prematurely wear out your ambles. Obviously, if your die cuts are out of register on your sheets, incomplete cutting, again, not cutting sufficiently deep enough within the amble blanket through the sheet. Worn amble blankets. I'm not going to go through all of them, but there's a number of different things to look for when it comes to die cutting symptoms and possible causes. And again, I know I keep referring to the online course through the packaging school. That course goes into a lot more detail of symptoms and possible causes and remedies for that. And then lastly, we're going to talk about maintenance and cleaning. So there's a lot of basic guidelines for maintaining the equipment, and they're identified at the end of each job, the end of each shift, and daily, weekly, and then as needed. And these are some of just the general guidelines. Every manufacturer has very specifics that they like to maintain. Different plants have their own protocols for housekeeping and cleaning requirements. But the plant protocols should comply with the machinery manufacturer's protocols to ensure the machine performance and capabilities. Some of the basic rudimentary stuff is just to clean everything, keep scrap and debris off the machine, dust, debris, any ink sling or any ink leakage and dried up inks should be removed from the machine as well. And then maintenance and preventative maintenance. So there's daily maintenance, weekly maintenance, monthly maintenance. In some cases, there's semi-annual maintenance and then annual maintenance that needs to be done on these machines. It's very important to follow machinery manufacturer's protocols for this. That ensures the warranty levels of the machine and keeps the machine operating at its optimal performance. So in conclusion, a successful REC machine performance is a result of quality manufacturing processes, good maintenance and housekeeping practices, safe operation, and well-trained crews. So we'll finish up with any questions and comments.
Thank you, Eric. To the audience, if you have any questions, you can go ahead and post them in the chat area, and Chelsea will let us know if there's a question, or I'll see. We do have a question. Can you explain applying glycerin to scores?
No, I cannot.
Okay.
I've never heard of that. I personally have never heard of that process.
Ed, if you want to post a little bit more about it, I can. We can get more information on it, and I can do some research as well. If anybody else has any questions, please feel free to post it in the chat. You know, you talked a lot about setup, and I've heard a lot about that throughout my years at AICC, and as being really crucial in the machine, you know, in running a machine. And I'm wondering, when you go into a machine plant and you see companies, you know, getting ready to do a job, if you find any discrepancies in how they do setup, or where their challenges lie as it relates to setting up.
Yeah, well, that's a good subject to touch on. So, you know, most machines have designed set up criteria within them. So, some manufacturers will say a machine can set up in 10 minutes, others will say 20 minutes, it varies from machine to machine, and some machines can set up quicker than others. But really, that's in ideal conditions. In order to get ideal conditions has a lot to do with operator training and plant supervision and plant expectations. So an operator can't be expected to set up a machine in 10 minutes if his printing plates aren't pre-staged next to the machine. It's just no way that's going to happen. His inks have to be formulated and pre-staged next to the machine. He has to have all the components needed, to the proper pull bands by the machine. So a lot of effort needs to be placed in presenting, or a lot of effort has to be in place to make sure that the next order is pre-staged properly, so that the operators can get in and out of the machine as quickly as possible. And without having those components in place, setup times will be extended. So again, us as machinery manufacturers, we can't stress enough, having the right equipment and the right procedures in place to pre-stage the next order.
So it requires quite a team then. It's not just that, it can't just be the operator that's running the machine. There's all these people that have to make sure.
But it's a lot of planned, coordinated effort.
Yeah. Going back to the question about glycerin on scores, maybe there's a misunderstanding. Apparently it's on one of the slides you just reviewed.
No, I didn't see that.
So I don't know if you can go back and see if maybe we can research it and get back to the group afterward.
Amy, Tara?
Oh, Ed, are you on? Yeah, go ahead.
So it was just, I guess it was like troubleshooting. It was like 2 slides back, and there was like all troubleshooting stuff, and it was if there's score cracking or checking, and one of the remedies was to apply glycerin to the scores. I'd never heard of that before.
Okay.
It's just, glycerin's like a lubricant. So I'm just curious, like.
Yeah, I'm not quite sure how that got in there either. That was something that so the troubleshooting guidelines came from something we put together with in the packaging school with the Clemson University. So that may have been a carryover from something else. I'd have to look into that and see how or why that verbiage made it into the remedy.
Yeah, Eric, can you let us know and get back to us, and then we'll go out to the group with what we found out from that.
Okay.
That'd be awesome. Might have a solution for you, Ed, that we didn't know about.
Yeah, thanks.
Okay. Does anybody else have any other questions? There's one more here. You talked about dirty ink systems, and I'm curious, how do you remedy that, or what are some challenges, or how do you know that that's probably the problem?
So dirty ink systems, there's a number of things that constitute a dirty ink system. Obviously ink dust and debris. So you want to make sure all guarding is in place, and before and after every shift, you want to make sure you blow out the machine and remove any dust that's collected. Die cutting creates dust. There's no way of getting around it. I mean, the whole process of cutting into the corrugated sheet creates dust, and dust gets everywhere. Also, vacuum transfer machines pull dust from all elsewhere in the plant. If you have, a single rotary die cut machine with vacuum transfer, and the rest of your machines are older traditional pull roll machines, all the dust is going to get pulled to that vacuum transfer machine just through the nature of the vacuum itself. So they collect dust. So it's a very important to keep a very clean environment around a rotary die cutter, and keep keep the dust out of the ink.
Okay.
But again, a lot of that is with guarding, making sure all guarding is in place, and making sure your systems are flushed properly in between color changes. and your inks are kept clean. Make sure the proper additives are used within your inks to maintain viscosity and pH levels. And keep, most importantly, debris. You know, ink pumps are prone to contamination, to failing because of contamination, whether it's through paper scrap or order tickets or miscellaneous pieces of paper getting pulled into the machine. They tend to clog up.
Okay. Well, there's no other questions, so thank you very much. I do want to say you did a lot of, there's quite a bit of conversation on dust, and for those that are on the call, we will be doing a webinar on dust within, well, we don't have the dates yet, but it should be within the next 2 months. So if you're interested in finding out more about that, please let us know or keep in touch with me and Chelsea, and we'll also send a note out to the group once the dates have been finalized. Again, thank you everyone for coming, and as you know, there's all these webinars up on our site, and we're adding more daily. So be sure and register for them. If you've signed up for the All Access Pass starting on January 1, we will have a total, again, a total of 50 webinars that will be offered. And you as current All Access Pass providers, All Access Pass companies will have access to those. And if you haven't been a part of the All Access Pass and you want to get involved, 50 webinars is a great opportunity for you, your company, and your employees. Look forward to talking to you all again. Thank you so much, Eric. This was very informative. I always feel like I learned more about machines than I ever thought I could ever know.
And I kept it within my time slot.
You did perfectly. Thank you. Talk to y'all later.
Thank you.
All right. Bye-bye.